we have a wooden plank and a 20 kilogram block on it, and we want to find some things, so let's go ahead and do a free body diagram. I have the normal, I have the weight, and I have the friction force going up like this. Now I need to split the weight into the proper components. So I have Wx and Wy. So the forces are balanced, so I know Wx balances the friction, and I know that Wy balances the normal force. So I'll actually write those here. And let's go ahead and do our calculation. So I have friction equals 20 times 9.8 times the cosine, and let's remember that for theta, we don't use theta in our formula. It's going to be 90 minus 17. And similarly for our normal force calculation, we're going to actually do the normal force equals the sine. So the normal is going to be 20 times 9.8 times the sine of 90 minus 17. And so when we work on our math, we're going to actually end up getting for the normal force 57 newtons. That typo. And for the friction force, you know what? I actually got that backwards. The friction force is 57 newtons. And the normal force is going to end up being something else entirely when we do our math. So I'll go ahead and get that now. That's going to end up being 187 newtons. So mu is going to be 57 divided by 187. So that's going to work out to be about 0.3. Now, if the friction were negligible, what would the acceleration be? So we're going to actually go ahead and get that now. So what that means is we're going to have a very similar free body diagram, but there's going to be some key differences. One key difference is that our friction force now dies out. And so we don't actually have to worry about that, so we'll just get rid of it in our free body diagram. And we'll go ahead and we will calculate the Wx, Wy. I'll tell you right now, normal equals Wy because those bounce. What we're really concerned with is the acceleration of the block. So I can actually use my value from before. I can actually say that 57, because that's 20 times 9.8 times cosine of 73, equals 20 times a. And so when I solve for a, I'm going to actually end up getting nearly 3 meters per second squared, 2.85. Now, for part C, I'm going to actually let you work on that on your own because it just may be a bonus problem on your exam.